Hey everybody, it's Jane from Norman That's Right. In this week's video, I want to talk about heat recovery ventilation and energy recovery ventilation, how they're different and how they work. So let's get started. So let's start with the difference. A heat recovery ventilator, or HRV, recovers the heat in the exhaust air of a building's HVAC system. An energy recovery ventilator, or ERV, recovers the heat and moisture in the exhaust air. They both use this recovered heat and moisture for the ERV to pre-treat the incoming ventilation air. The total heat of energy in air is called enthalpy. Let me make a little bit of room. Enthalpy is made up of sensible heat, which is usually thought of as temperature, and latent heat, which we think of as humidity. So ERVs are sometimes also called enthalpy recovery ventilators. Let's move this over. ERVs and HRVs allow you to pre-cool and dehumidify or preheat and humidify using free energy from your exhaust air, which saves you energy and money. I'm going to refer to them as ERVs through much of this video, but the basic heat transfer concept is the same. Just remember that HRVs only recover heat. So there are different types of ERVs. Some use a rotating wheel and some use a fixed plate. So let's draw a basic ERV or HRV. We'll start with the wheel design. So I'm going to draw the wheel in the frame first. So you have a wheel in a frame and it's separated like this. So it'll rotate through two separate sections in the ERV unit. Now if we put it in a cabinet like this, and then the wheel is here in the middle, we have fans over here to move the air in and out of the ERV. The outside air comes in here, goes through the wheel, and is blown out of the unit to become supply air over here. And we'll get to the details of this in a minute. The return air is pulled into this section and would pass through the lower half of the rotating wheel and then be exhausted out of the unit. So let me make room and look at the fixed plate design. There's two types of fixed plate designs, crossflow and counterflow. So the crossflow design looks like this. We'll draw the cabinet, and the plate section is here in the middle, and then all these quadrants are separated. We have fans over here, so the outside air enters here and passes through the plate in this direction. Then this fan blows the supply air out. The return air comes in here and passes through the plate in this direction, and it's exhausted out here. In a crossflow design, the two air streams flow perpendicular to each other. So you see that happening right here. The plates are made with channels, so if you look from the side, it'll look kind of like this, with openings on one side like this, and openings on the other side like this. And so the air can come in this way on this side, and then on this side it flows perpendicular this way. So let's move that over and look at counterflow. Counterflow plate ERVs kind of look like this. Again, we have a cabinet, and we've got the fixed plate core here in the center. And then the air streams are separated again. Outside air comes in here, passes through the heat exchanger, and then goes out to the supply air down here. Return air comes in here, passes through the plates again, and exits as exhaust through here. Let me move this up just a little bit. So again, there are channels in here that are directing the airflow in one direction or the other. These channels allow the airflow to run parallel to each other but in opposite directions. Because the air streams move in opposite directions, it maximizes the temperature difference between the air streams, leading to higher heat exchange. So now let's look at the way the air moves through the ERV. The concept is again the same for ERVs and HRVs and for wheel and fixed plate units. So let's just work with this drawing, and I'm going to just make a copy of it and move it over here somewhere. In the summer, you have warm and, depending on where you are in the country, possibly humid outside air. So let's call it 90 degrees and 60% relative humidity. It comes into the unit and passes over the wheel or through the plates. If you have low humidity in your area, you may just be using an HRV instead of an ERV, so you can ignore the humidity part of this process. If you have high humidity, you might be using an ERV. The wheel or plate absorbs the humidity and heat, which is transferred from the air into the wheel or the plate. After the air passes through the wheel or plate, it's cooler and drier, maybe 80 degrees and 55% relative humidity. And you didn't need to use any energy to make that happen. From here, it moves into the HVAC system, and maybe there are cooling coils to get it to 55 degrees and 50% humidity to supply the space. The ERV or HRV reduced the energy needed to cool the air down by taking some of the heat and moisture out of it before it entered the cooling coil. Now the return air comes back from the space, say at 75 degrees and 50% humidity, and passes through the wheel or plate channels again. With the fixed plate, the heat and moisture transfer happens as the two airstreams pass through the plate channels. With the wheel design, the wheel is rotating so it passes through both sides of the airstream. The return air passes through the heat exchanger and it's exhausted outside the building at maybe 85 degrees and 55% humidity. Let's make another copy of this and look at the winter operation. In the winter, the outside air is cool and dry, but the inside air is warm and humid. So the outside air picks up heat and humidity from the wheel or the plate that was left there by the return air and supplies it back into the space. So the outside air can come in at, say, 30 degrees and 30% humidity, pass through the heat exchanger and is now 55 degrees and 35% humidity. Then it goes to the space at 55 degrees and 50% humidity. So it's either heated or cooled to get to the space. And then when the return air comes back, it's 75 degrees and 40% humidity, let's say. And then after it passes through the wheel or the plates again, it's 45 degrees and 35% humidity as it's exhausted out of the building. The ERV or HRV allows you to use heat from the return air to preheat the cold outside air for free in the winter. Now let me move this over one more time. The HRV or ERV wheel or plate can be made of metal or from a polymer. Metal wheels can only transfer heat. Polymer wheels can be impregnated with a desiccant that can absorb and release moisture. Fixed plate heat exchangers are generally larger than wheels, but they have no moving parts. Your outdoor conditions would determine the effectiveness and whether you should use an ERV or an HRV. But ERVs and HRVs can help save energy and reduce your HVAC equipment size. So let's bring all this back on. So that's how HRVs and ERVs work. As always, you can contact your Norman Wright salesperson for more information on ERVs and HRVs. If you have any questions or suggestions for future videos, please put them in the comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.